Okay, if we look at this function and we look at what's going on right here, this would indicate what type of function it is. So we're trying to identify the base function. We can say that it would be y is equal to root x because that would be a square root function. And same idea as before, what happens on the outside will affect y, and what happens on the inside of the square root will affect x. So in this case, we can say that there is a vertical reflection in the x-axis. We can say that there's a horizontal stretch of 2, a horizontal translation left 7, and a vertical translation up 5. If we look, the square root only goes to the end of the brackets, which means this is outside of it, or under the square root. Now we want to look at what the base function does. So we have y is equal to root x. So I need to pick values of x that make sense. I want to pick values of x where I can take the square root. Also, I can't pick negative values because the square root of negative values does not exist in real numbers. So if I look, I'm going to pick 0, 1, and then I'm going to pick 4 because I can take its square root. I'm going to pick 9, 16, and 25. I'm going to pick perfect squares. So the square root of 0 is 0, square root of 1 is 1. This will be 2, 3, 4, and 5. And if I need more values, I can do 36, which will give me 6. So y is affected anything on the outside, and x is for anything on the inside. So that means I'm going to multiply by 2 and subtract 7. And this means I'm going to multiply by negative 1 and add 5. But let's look at, first and foremost, what does that square root function actually look like? So that's what this little box is for. So at 0 we get 0. At 1 we're at 1. At 4 we're at 2. At 9 we're at 3. 10, 11, 12, 13, 14, 15, 16, 1, 2, 3, 4, we're at 4. So this is what the base function looks like. So now I can draw the transform function, and so let's go and do that table. So I'm going to multiply all these by 2 and subtract 7. So I'm going to get minus 7, minus 5, 1, 11, 25, and 43. And then I'm going to take the y values, I'm going to multiply by negative 1 and add 5. So I get 5, 4, 3, 2, 1, 0. Now again, not all of these are going to fit on the graph, but we'll do our best. So at minus 7, we're at 1, 2, 3, 4, 5. 11, 1, 2. Okay, so that gives us our general outline. And it looks like that. It does not extend in the other direction because, as you can see here, it has to start at 0, 0 and goes in one direction. It's like half a problem. Okay, if I look at the next one, my base function is going to be 1 over x because everything else is a transformation. So if I look, I have 1 over x, and this is known as a rational function. So this is on the inside, so we have a horizontal reflection In the y-axis, we have a horizontal translation, left 4, and we have a vertical translation, down 2. So again, let's look at the base function. That is y is equal to 1 over x. So I'm going to go with minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So if I do that, I get negative a quarter, negative a third, negative a half, negative 1. But if I try to divide by 0, I can't. So what I get is undefined. Then I get 1, a half, a third, a quarter. X will be affected by anything on the inside, so the plus 4 and the minus. Y will be affected by anything on the outside. So it means I can times by negative 1 and subtract 4, and then I can subtract 2. So let's look at what that base function is going to look like first. So at minus 4, I'm at a quarter, I'm at a third, negative a half, and then negative 1. Then it's undefined. At 1, I'm at 1. Sorry, this is in the wrong spot. Sorry, negative here, 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 and here. And then we're at 1, 1. We're at 2 and a half, and a third, and a quarter. So if I look, although not as many dots as I would like, what's happening is we're coming along here, and we get to here. The only place to go is down. So it actually does go down in that direction. And for this, the only place for it to go once it gets here is up. And then it comes around. So what it does is it actually forms two asymptotes. One along here that it doesn't touch, and one along here that it also doesn't touch. So there's one at y equals 0, and there's another one at x equals 0. This is the horizontal asymptote. This is the vertical asymptote. So let's look at what our new graph is going to look like. So I'm going to multiply everything in the x column by negative 1 and subtract 4. So I'm going to get 0, 1, 2, 3, 4. Sorry. I'm going to get 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. In the y column, we're going to subtract 2 from everything. So I'm going to get minus 2.25, minus 2.33, minus 2.5, minus 3. This again will be undefined. Minus 1, minus 1.5, minus 1.67, minus 1.75. So let's see where this goes. So we have 0 and minus 2.25, minus 1, 2.33, minus 2 and 2.5, minus 3, minus 3. Oh my goodness, I'm going in the wrong direction again. Sorry, minus 1 and minus 3. Minus 2.5. Minus 3, minus 3. That's 0 and minus 2.25 is there. There we go. And at minus 4, we're undefined. So that means that at minus 4, there has to be an asymptote. And it also appears that we're going to get close to minus 2, which comes from there. So that's going to be our other asymptote. So while we don't have a ton of points, this is going to do this. Okay, let's draw the other one. So at minus 5, we're at minus 1. At minus 6, we're at minus 1.5, 6, 7, and 7, 5. So this part is going to do this.